Okay, I give you here another example, but this one is not in the slide provided. Okay, we want to find the volume of the region bounded above by. So here maybe the word is a bit confusing. Above, bounded above by the z, below by the z equal to 0, laterally by the x squared plus y squared. So the word of above by the z, meaning that your upper bound is below. Okay, above by the, what is this? So z equal to 4 minus x squared y squared is, if you sketch this, you have a ball concave down, isn't it? Concave down. This is a ball concave down, where this one is 4. This is z, x, and this is y. Okay, so now z0 is the floor, and laterally is if you have the x squared plus y squared, so let's say I'm just equal 1, so we have a circle with radius 1 centered at the origin, isn't it, on y-x plane. So laterally in Malay just like dikelilingi oleh the circle with radius 1, laterally. Okay, but now again we want to understand what is the meaning of the word, the sentence here. We have a solid. The solid is bounded above by the z. In Malay, I would say dibatasi atas oleh siapa. Okay, above by whom? Okay, by the ball, and bounded below by the floor. Dibatasi bawah oleh siapa? Dibatasi bawah oleh plane z equal to 0. Okay, so if you don't really concern, there is a difference between, if I change, I throw away the word by, just bounded above the z, what can you understand? Above the z of the 4 minus x squared y squared, above. So above meaning that outside the bowl, but in this case bounded above by, so dibatasi atas oleh bowl. Right? So just imagine if I throw away the word above. So what you can understand is your solid bounded by, okay, bounded by the z, bounded by the z equal to, and by z equal to 0. So if I throw away the word above, so it still makes sense, right? The region bounded by the ball and the plane, bounded by the ball and the plane. But if there is a word above here, meaning that it is mentioning that your boundary, your upper bound is from the ball itself. Okay, just like I provide you in the notes, you have to take attention for these sentences. Okay, so what is the sentences that you have to take note? There is a word bounded below by, or you have a bounded above the, or you have bounded above by. Okay, so as I mentioned here, bounded below, or bounded above the, and bounded below or bounded above by, they are different. So maybe you think that the first word, so the first word here, the first and the second, they are the same, but they are not the same. Okay, above the and above by. So what we can take note here is bounded below by, meaning they have a same meaning as bounded above the. Okay, so let's say bounded below by the line y equal to x. Bounded below by the line y equal to x is the same meaning as bounded above the line of y equal to x. Or if you have a bounded above by the line y equal to x, is the similar meaning as bounded below the line of y equal to x. Okay, but in this case, it is region here means maybe the word region is not suitable here. Maybe we can say a solid because we have the solid, not the region, right? Find the volume of the solid where the solid is bounded above by the ball and below by the floor. And laterally is based on the cylinder. So this one, if we sketch this in 3D, so this one is actually a cylinder with radius 1. Okay, so meaning that our solid is actually not in this form. So you should provide the inside the bowl you have, okay, so what size of the circle when z equal to 0? So when you replace z equal to 0, you have 4 minus x squared minus y squared, which means that you have x squared plus y squared equal to 4. You have a larger circle because for this one, your circle is radius 1. But for the ball, when it is lying on the z equal to 0, we have 2. So meaning that this one you have 2. Okay, so when you plug in the cylinder with radius 1, so you have a smaller cylinder. So let's say, so you have a smaller cylinder radius 1. So this is your cylinder. Okay, so meaning that your exact solid, which based on the information provided, you have so laterally by the cylinder with radius 1, 1 and 1, and you have the one here, and then you can see your cover is not flat, right? It's coming, or it is part of the bowl, the blue bowl, where that is your bowl with radius 2 when z equal to 0. So this is actually your solid. Okay, now we read again whether our solid is correct. So we want to get the volume of the solid bounded above by the ball. This is the ball, above by the ball, and below by z equal to 0, and laterally dikelilingi oleh, laterally is bounded by the cylinder with radius 1. Okay, so this is your solid. So now you want to get the volume using triple integral. You have to use a dv. So what kind of solid that you have here? If this is your orientation and you are standing like this, so your type of solid is called as xy solid, which means that your dv is dz d dA on xy plane. So dz dA x y. Alright, so now we want to obtain the limit of z. The limit of z is the first integral. So to get the limit of z, the first integral, you have to look at from your solid. So who is covering you? Who is become your lower bound? Z equal to 0. And who is covering you? The surface that covering you is the bowl. So what is the formula of bowl? 4 minus x squared minus y squared. So now we already have the limit of z, 0 to 4 minus x squared minus y squared. Okay, how about your region? So your region is, now look at your solid. So what is the curve that you can see lying on xy plane? So you can see this circle with radius 1, right? Where it is part of your trace here. So because of your region is part of the circle, then it is more easier for us to solve because your equation here is x squared plus y squared. So we don't want to deal with the square root plus minus square root and so on. So in order to we don't want to use that such a messy thing, so we can transform into polar equation with the condition that your region is part of the circle or part of the polar equation. So now in this case we can change the dA here into polar. So because of we have a circular region which based on circle, so we can transform into polar coordinate system only for dA, which is dy dx, but z fixed. So to do that, you have to put the dA in polar. So what is dA in polar? We have learned in double integral. You have r dr d theta. So you can have part of your dv in polar, you can have r dz dr d theta. Okay, so the polar, when you apply the polar in triple integral, so we call that as a cylindrical coordinate, where I will explain to you about the cylindrical coordinate after this on the next video. For this, I just want to show you when and how can we implement the cylindrical coordinate. So you can implement the cylindrical coordinate in triple integral when your region is a circle on xy plane. Okay, so then your dv now is become dz r dr d theta, or you can have r dz dr d theta. So this is called cylindrical coordinate. So cylindrical coordinate is the extension of polar. But polar, you just have xy and you just have r and theta, right? But in triple integral, you have the r and theta and also z. So z is z. In cylindrical, z is z. Xy you have to convert into polar, which is become r and theta. So when you solve that using polar, so then it's end up to be, so I put the dv now, so r dz dr d theta. So your limit of theta, your limit of z, because your limit here, your upper bound of z is still in terms of xy. As I mentioned before, in cylindrical coordinate, z is z, you don't change the z, but you have to change the xy into polar. So your new z in polar or cylindrical becomes 4 minus r square. Because we know that 4 minus, when we factorize the negative 1, so we have this, where x squared plus y squared is r squared. So that's why we have 4 minus r squared. So then we substitute the limit of z now in terms of r and theta become 0 to 4 minus r. And how about the limit of r and theta? So we no longer have the x and y, but we transform into r and theta. And since our region is a circle centered at the origin, so the limit of theta and r, they are all constant. So we have a complete circle, so theta from 0 to 2 pi. And r, how can we determine the limit of r? Exactly as in the double integral. So you have to draw a line starting at the origin. So you can see that the origin is part of the circle. So your r is 0 and the highest r is at 1. So you can have theta 0 to 2 pi and you can have r 0 to 1. So now we can evaluate the volume of this particular solid in terms by using cylindrical coordinate. So how can we evaluate? So the standard process, you have to first remember r here will be part of your integral, okay, because it's coming from dA. So first we have to integrate with respect to z. So r constant. So r z 0 4 minus r dr d theta. So you have this one 4 minus r squared. So 4 minus r squared dr d theta. Okay, so when we expand, we have 4r minus r cubed, and we integrate with respect to r. We have 2r squared minus 1 over 4r4, and then we replace the limit of r, and then after that we integrate with respect to theta, d theta, and we will get 7 pi over 2. Okay, you can use the Cartesian coordinate, but as we know that when for this one about the limit of x and y, they should contain the plus minus square root, and your calculation is more tedious. It can be done, but you need an extra more longer steps. You have to apply some trigonometric substitution and so on, compared with if you solve using polar. So your calculation is just a bit simpler, but the condition with the condition that first you have to convert into polar, or in triple integral we call this as cylindrical coordinate. Okay, so I will give you more example about the cylindrical coordinates on the next video.